Okay, in this video, I'm going to go over the two examples that I have listed over here. And it says, describe the graph as a transformation from its parent function, sketch two full periods, identify the important characteristics of the graph, if any, amplitude, period, phase shift, vertical asymptotes, x-intercepts, domain, and range. Okay, so let's quickly review our transformations, right? So there's no such thing as a real amplitude in your tan and cotangent, tangent and cotangent functions. But you know, the absolute value of A is still greater than 1, so I can say vertical stretch by a factor of 4. Right, and then of course this is my B value, right? The B value tells you your horizontal shrink or stretch factor. The absolute value of B is greater than 1. I say it's a horizontal shrink by factor of 1 over B, okay, 1 over pi. Okay, so go back and review your transformation notes if you forgot what those are. Okay, so now how do I actually graph it? How do I get the important characteristics? The first thing I'm going to do is calculate the period. Okay, so the period, right, as I mentioned, is just pi over b, and the b in this case is just pi. So the period of this function is 1. The next thing that's really important is the vertical asymptotes. Okay, so the phase shift on this problem right here, there is no phase shift. We could just say none. Okay, there's no shifting of the graph. And the VA, which is probably the most important thing. All right, so when you calculate the VA, right, you have to remember your quotient property, right? The tangent of pi over x is the same thing as 4 sine of pi over x over the cosine of pi over x. And the way you calculate the VA is by setting the denominator equal to 0. So let's do that. So for cosine of pi over x, I'm going to set it equal to 0. Okay, so what's going to happen right now is we're going to have to solve a trig equation that's basically called a multiple angle equation. And without confusing you guys more, it just means there's more than one solution to this problem. And so there's an argument typically inside your trig function that's other than just a single x, right? There could be a number here. It could be some kind of constant. And the way I solve this is typically I call this theta, okay? So I'm going to say cosine of theta is equal to 0. Right, I let theta equal pi over x. And you've solved the equation like this before in your secant and cosecant. So this is no different in that way. All right, so if I ask you, hey, find the values for cosine, which is 0, right? Find the values of theta, which cosine is 0. The x value is 0, right? You would say theta is equal to pi over 2, or theta is equal to 3 pi over 2. Again, these are values in the unit circle for which the x value is 0. Okay, but you're not solving for theta, right? You're solving for x. So a lot of times students forget to solve for x. They make sure you plug the pi over x back into for theta here. So pi x is equal to pi over 2. And if you divide by pi on both sides, you're going to get x is equal to 1/2. Set pi x equal to 3 pi over 2. These pi's are going to cancel out on both sides, right? You're going to get x is equal to 3 over 2. Okay, so I have the first two VAs, and I want all the VAs, right? You would say all x is equal to 1/2 plus the distance between here and here. 3 over 2 minus 1 over 2 is 2 over 2, which is just 1, right? Which, remember, I told you this is essentially the period, right? This number is the period, which we calculated over here, right? Pi over pi is 1. Or you could verify right minus left. 3 over 2 minus 1 over 2 will give you 2 over 2. Which is just 1. Okay, so these are all your VAs. And you can calculate the domain while you're at it. You can say all x cannot equal to 1/2 plus n. And then, of course, you know the range for these problems, right? Minus infinity to infinity. Let's say you wanted to calculate all the x-intercepts, right? You can calculate all the x-intercepts by finding the midpoint between the first two VAs. And the midpoint between these two VAs, right, is 1/2 plus 3 over 2 times 1/2, which is, looks like it's 4 over 2, which is 2 times 1/2. So your first x-intercept, right, is going to be 1. And to get all the x-intercepts, you would say all x is equal to 1, right, plus the period. And the period we said was just 1n, okay? So if you take a look, right, we did quite a bit of analysis, right? We got the domain, we got the range, the x-intercepts, all the VAs, right, phase shift and period, and then of course we were asked to compare with the parent function of tangent x before we plotted a single point. Okay, so let's graph this. Let's put everything together. We're going to sketch 2 full periods. And my first two VAs are 1/2. And 3 over 2. Okay, so if I ask you to sketch 2 periods, right, going this direction, because the period is 1, right, if I subtract 1 from 1/2, I'm going to get negative 1/2. And because the, I guess this is called the fake amplitude for your tangent function is 4, why don't you label your y-axis as -4 and +4? Okay, so for our x-intercept, right, we said one of the ones that we calculated was 1, right? So the 1 would be right here. Another x-intercept would be 0. And the way you would sketch it now is, remember, the distance between the x-intercept and the vertical asymptote, right? The midpoint, I should say, between the x-intercept and the vertical asymptote, you basically go up to the positive amplitude. And the distance between this x-intercept and this vertical asymptote, right, you go down to the negative amplitude. And now you can sketch. It's the same thing over here, right? If I say, hey, what's the midpoint between 1 and 1/2, right? You would calculate that. And wherever that point is, right, it's going to go down to the negative amplitude of -4. If I say, hey, what's this point right here, right? Again, you can calculate the midpoint, right? You could say 1 plus 3 over 2 divided by 2, of which you're going to get 5 over 2 times 1 over 2, which is 5 over 4. So this point right here is 5 over 4, right? The key is I want you to see that the midpoint between the x-intercept and the vertical asymptote, it goes up to the positive amplitude. This midpoint right here goes down to the negative amplitude, right? You could do 1 plus 1/2 and divide that by 2 as well, right? Which is 3/4. So this coordinate right here is 3/4. So at 3/4, it's going to go down to -4. And this will be kind of helpful for you as you write the equation of the graph. Sometimes they give you the equation, I believe, in your homework, and you're asked to write the equation, right? And so what I would do is go to the midpoint between the x-intercept and the vertical asymptote and see what y value goes up to. Whatever y value goes up to, that's the amplitude or the fake amplitude. So that will conclude your tangent function. And the way you graph the cotangent function, if you take a look at example number 2 or problem number 4, it's very, very similar. Okay, so this time we actually have a phase shift, but keep in mind we have a reflection across the x-axis. Okay, so the first thing I'm going to say is make a comparison to the parent function. You could say since a is less than 0, reflection across the x. You can say, hey, it's shifted pi over 4 to the left. Okay, and that's how this graph is different from f of x is equal to cotangent of x. Okay, so that's a little review of your transformations. Okay, so the way you calculate the period, right, there's a formula. It's pi over b. Okay, so it's no longer pi over, or 2 pi over b. It's pi over b. In this case, the b value is 1. So the period is just pi. The phase shift, right, this time we do have a PS, a phase shift, which is negative pi over 4 to the left. And the most important thing, as I mentioned, right, is to calculate those vertical asymptotes without using a calculator. Okay, so a cotangent function, right, the cotan of x plus pi over 4 is the same thing as cosine of x plus pi over 4 divided by sine of x plus pi over 4. Okay, so the way you calculate the vertical asymptote, right, is to set the denominator equal to 0. So let's do that. Sine of x plus pi over 4 is equal to 0. Okay, so again, this looks like a complicated equation. It's called a multiple angle equation, which you'll later learn in math analysis. Call this guy right here theta, and make it easier for yourself. Call it sine theta is equal to 0. And of course, just like what you solved earlier in the parent functions for tangent and cotangent, right? You need to use the unit circle to figure out what values or what y values for theta is sine 0, right? And so theta is going to equal 0, or theta is going to equal pi, right? So again, we're not trying to solve for theta, okay? So don't just leave it like here. You have to plug x plus pi over 4, which is equal to theta, back into this equation. You have to say x plus pi over 4 is equal to 0, or x plus pi over 4 is equal to pi, right? Because I'm trying to solve for x, basically, not trying to solve for theta. This is just to make my equation a little bit easier. Okay, so solve this one-step equation. Your first vertical asymptote is negative pi over 4. Your next vertical asymptote, right, pi minus pi over 4 is 3 pi over 4. And these are your first two VAs. And if I say calculate all the VAs, right, you would say, you could write negative pi over 4 plus the period, right? The period we calculated was just pi. But remember, by convention, typically we write the first least positive the first least positive vertical asymptote. So I'm going to write all x is equal to 3 pi over 4 plus pi n. So on a quiz or test, if you wrote negative pi over 4 plus pi n, that's not wrong. But just by convention, the way they write it is write the first least positive. In this case, it would be 3 pi over 4. Okay, so how'd you get this number? This number is the period. Why is it 3 pi over 4? It's just by convention. If you're negative pi over 4 plus pi n, it's not wrong. Okay, so you can state the domain while you're at it, right? All x cannot equal 3 pi over 4 plus pi n. The range you can probably just memorize, right? Minus infinity to infinity. And if I say, hey, what are the x-intercepts of this graph? By the way, on our last problem right here, notice for my x-intercept, I wrote 1 plus n. Had you wrote 0 plus n, that's the same thing, okay? You could write all x is equal to 0 plus n, right? This is the first least positive x-intercept. Or x is equal to n, that works as well, okay? So 1 plus n works, 0 plus n, which is the same thing as x is equal to n, that works as well. The reason why I had 1 here is because I calculate the midpoint between these two values. Okay, so likewise, right, if I say, hey, give me the first x-intercept, well, I take a look at my first two VAs, right? I could say, hey, what's the x-intercept between these two values? Or what's the midpoint between these two values, right? And I calculate it, and I'm going to get 2 pi over 4, right? This plus this is 2 pi over 4, which is pi over 2, times 1/2. My first x-intercept is going to be pi over 4. And how'd you get that? I calculate the midpoint between these two. That's just the way these cotangent and tangent function works. Okay, so this is my first one. And I could say all x is equal to pi over 4, plus whatever the period is. The period, of course, we said was pi, right? So this will be all the x-intercepts. I haven't plotted a single point yet, and I pretty much did a lot of the analysis already, okay? All right, so we did all the work. We just need to put all this together on a graph. So let's do that. All right, so V at negative pi over 4. Next VA we said was 3 pi over 4, right? And our first x-intercept, right, which is going to just be pi over 4, is basically the midpoint between these two guys. And it looks like our amplitude, if we have one, a fake amplitude, so we want to label our y-axis from -2 to 2. So here's 2, here's -2. And normally, right, our cotangent function, right, the midpoint between these two guys, if I just say, hey, what's the midpoint between the x-intercept and this, right? If I just say calculate it for me real quick, you can calculate the midpoint. That's 4 pi over 4. And then I times it by 4 pi over 4, which is just pi, right? And I times it by 1/2. That's going to give me pi over 2. So this point right here is pi over 2. Okay? And if I say, hey, calculate this midpoint right here, you would say negative pi over 4 plus pi over 4 divided by 2, which is just 0. So really, this midpoint right here is just 0. Okay, so for our cotangent function, right, normally, you know, the, how should I say, the x value to the right of the x-intercept is, it goes down to the negative amplitude, right? And the x value to the left of the x-intercept goes to the positive amplitude, I would say normally. But you have to keep in mind that this function has a reflection across the x-axis. So you really just need to do the opposite. So instead of writing at pi over 2, it's at -2. You could do pi over 2 is going to be at +2. This is the x-intercept. And at 0, it's going to be at -2. Okay, so your graph's going to look almost like your tangent function. The reason why it kind of looks like your tangent function is because there's a reflection across the x-axis. And you can always double check your work by plugging in these points right here, right? If I plugged in 0, you're like, I don't know. How do I know it's going to be at -2, right? Let me make it a little more accurate. 0 is going to be at -2. How do I know it's going to be at -2? Well, if you plug in 0 back into this function, right? Let's see where I wrote the cosine function. Okay, so if I plug in 0, right, cosine of pi over 4, that's √2 over 2. Sine of pi over 4, right, that's also √2 over 2. And so √2 over 2 over √2 over 2, which is just 1, right? And of course, we have the -2 over here. You would be at -2. Okay, so likewise, if you plug in positive pi over 2 into this expression, you would end up with +2. I believe the ratio you should get is -1. Okay, so this is one period, right? They want us to sketch 2 periods. So you can go along the positive x-axis, right? If I say, hey, what's the next x-intercept? Or sorry, what's the next next vertical asymptote, right? Just add pi to this. So if you add pi to this, right, 4 pi over 4 is 7 pi over 4. And your graph will look identical. Okay, it would look something like this. Again, this, if I ask you, hey, what is this x-intercept? You can calculate the midpoint between these two. Or you could just say, hey, pi over 4 plus pi, right? Because the distance from here to here is a full period. That would just be 5 pi over 4. And of course, the midpoint between here and here would go to the positive amplitude. Midpoint between the x-intercept and this vertical asymptote would go to the negative amplitude, okay? So again, normally on the cotangent function, right, this value right here at this x is going to go to the negative y. At this x, the midpoint between here and here would go to the positive y. But I wrote it here, I got it flipped because there's a reflection across the x. Okay, so I hope these videos will help you get caught up on your tangent and cotangent homework. If you have any questions, you're always welcome to email me, make comments, and I'll try to get back to you.